So what do we think? Looking at the first one, at A. Is it a function?
Yeah.
Yes. Is it one-to-one?
No.
No, it's not. So it fails the horizontal line test. So A is not one-to-one. I'm doing A in pink. Is it discrete?
No.
No. Is it continuous? Yes. All right, then let's look at B. Is it a function?
Wait, yes.
Yes. Yes, it's a function. Is it one-to-one?
Yes. Yes.
I heard both answers there.
Yes,
What are we
it is.
thinking? Why? Defend it.
No, I didn't. For C?
For B.
B. We're on B. B.
Yes, it's one-to-one.
Defend it. Why?
Because when you do the horizontal line test, none of the dots connect.
It only hits one dot at a time. So this is our function test. This is our horizontal line test, which is one-to-one. I'm only ever hitting one dot at a time, never two. So that's how we do our one-to-one test. So yes, this one is one-to-one. So yes, it's a function. Yes, it's one-to-one. Is it discrete?
One B?
B. Yes. Yes. Is it continuous? No. Can it ever be both discrete and continuous? No. Because discrete means they're not connected, and continuous means everything's connected. All right, then let's look at C. I'm going to do that one in green. Is it a function? Yes. Yes, it is. These are all functions.
Yeah.
Is it one-to-one?
Yes.
Yes. It also passes our horizontal line test. I'm going to rewrite that yes because that was crazy. There we go. Is it discrete?
No.
No, because it's got some things that are connected. Is it continuous?
Wait, no.
Thank you. Awesome. All right. It's got this open circle here. So we would have to come here and then jump over. So no, it is not continuous. It is neither discrete nor continuous. This one you're supposed to see, my dear. Okay. Questions on these? Awesome. So, what we're going to start with today, we're going to kind of have two sets of vocab words instead of me throwing them all at you in one go. We're going to do two sets and talk about them. So, we're going to talk about linear functions and nonlinear functions to start with today. So if we look at the word linear function, or even just the word linear, what might they be about? There's a clue in the word. Lines. Exactly. So if it is a linear function, it's a line. I'm going to give us a little bit more detail than that, but that's exactly what it is. Ooh, change that so we don't do it. There we go. A linear function, the way we're going to define it, is an equation that is graphed as a straight line. So that's our definition for it. But unless we're actually looking at a graph, sometimes that's hard to pull back up. Jeez, it's so hot. My whiteboard trying to come back there. And so what we have is we have a couple of different ways we can write equations, because we're going to look at equations today too and see if we can figure out if it's linear just from the equation. And so our equations are going to come in two forms, or we can put them into one of two forms, which is our one we might know, which we've used before, y equals mx plus b. This is called slope-intercept form. We've seen it before. We also may get something called our standard form, which has our x's and y's on the same side. And we usually just say ax plus by equals c, where a, b, and c are all numbers. I have no idea why I wrote the number 4 instead of the word form. That is my brain this morning. There we go. And this is standard form or general form. You'll see it written as both. So they both have x's and y's. We can either have x and y on opposite sides of the equal sign, or we can have x and y on the same side of the equal sign. That's okay. What's really, really important is neither x nor y is in a denominator, and nobody's got an exponent. X and y do not have exponents that are other than 1. So a nonlinear function is pretty much anything that's not that. It's anything that's not a line. So our nonlinear functions are going to be defined as a function whose graph does not sit on a straight line. And what we're going to do is we're going to start by looking at equations and seeing if we can tell if they are or are not linear just from the equation. We're not going to be plotting and graphing. We're just going to look at it and see if we can figure it out. So we may have to move some things around in the equations. We may see some things written in some strange ways, but we're going to see if they're linear or nonlinear. So nonlinear functions are going to automatically be anything with an exponent on a variable anytime we have x or y in a denominator. Okay? So that's what we're going to start with. Is it linear or nonlinear? Boop. So our first question is this a linear function or a nonlinear function? And I see an x, but I don't even see a y. To say we've seen this notation before, but again, it's been at least since last year. This f of x thing, this f parentheses x, this guy, that is y with a fake mustache on. He's in disguise. He's hiding. That is why he is y. He's just in a super duper fancy schmancy disguise. So we can absolutely rewrite this as not with a single change, just switching this to be a y equals 6x minus 5 all over 3. This is called function notation. And we are going to see it repeatedly this year. All this stands for is a function that has x as a variable. It's just y in a fancy suit. It's y with a mustache. He's in sunglasses. He's in incognito mode. It's just y. So f of x, the whole chunker, means y. So now let's look at the right-hand side. So I've got a y equals. What do we think? Is this possibly linear, possibly nonlinear? What are we thinking? It's kind of icky as the one big fraction, huh? We don't like big fractions. So when we have fractions like this, we have two options. I can either keep it on the one side and simplify, or we can multiply both sides by 3 in order to make it not have any fractions at all. I'm going to keep it on the same side right now because we're not going to do a ton of solving. So what I'm going to do is I'm going to uncommon this denominator. Really what I'm going to do is I'm going to split this into two fractions. So I'm going to take this to be y equals 6 over 3x, or 6x over 3, minus 5 over 3. So we have to have them as common denominators to be able to combine them, right? Does that help us see anything? Look at this piece. 6 over 3. Yeah. 6 divided by 3 is 2. So what this really is, and I'm going to give myself a little bit more space. Oh. No. Okay. I guess I'm just going to move that guy up. It's not letting me do anything. All right. So we have our y equals 2x minus 5/3. Now can we see if this is linear or not linear? Remember, our linear functions come into two forms. Or x plus by equals c. Does this look like one of those two that I just wrote up there? Yeah, which one does it look like? Y equals mx plus b, my slope-intercept form. So just because it has fractions in it doesn't mean it's not a linear. We can have fractions. We're going to have fractions. We're going to have decimals. Things are going to get gross. So this one is linear. It's in slope-intercept form once we got down here. Our intercept's gross, but this is linear. So we may have to massage equations around to see if it is. But once we can spot either my mx plus b or that I have my x and y on the same side and they're being added, then we know it's going to be linear. So let's try that again. Let's try another one.
How do you get 2 from 6 over 6x?
So 6x over 3, we can just like cover up the x right here. 6 divided by 3. Okay? We can simplify like that because the x is still hanging out. 6 over 3 simplifies down to be 2. So that's just 6 divided by 3. Okay, let's look at another one. We want to know if this is linear or nonlinear. We've got 5y equals 4 plus 3x squared. What do we think?
But we gotta get that 5 away.
I was like, if we want to get the 5 away, we can. What do you mean get the 5 away? How would we do that? So let's see. I'll put it right above it. Y equals mx plus b. What do we think? Remember, what are my rules for linear? X and y, and it can't have any exponents on my letters, right? So we're not going to be doing anything with the exponent. But do we see that we have an exponent here? I've got an x squared. So this is nonlinear. If my x is being squared, or to the third, or to any power, not a line. We're going to graph these by the end of the semester. Like, we're going to do these. But all we're looking at right now is it a line or not a line? So this is non-linear. I'm going to toss a couple more of these up because we need a little bit more practice with this. So, let me go with 3x plus 2y equals 7 and 4xy equals 8. And then we'll look at 3x cubed minus y squared equals 2. And we'll look at 1/4 y equals 3x plus 7. Okay, we're just going to practice this again. All I care about is, are they lines or not lines? And I just like straight up made these up.
The 3x plus 2y equals 7 is linear.
This is linear. My x's and y's are on the same side. This one is in our standard form. I don't have any exponents on my x or on my y. So this one is linear. It's in our standard form. I'm just going to mark it down so we see it.
The next one next to it is not.
Why?
It doesn't have an X. Or what's that thing in the middle? Is the X. That's the X.
It's got an x
Multiplied by the Y.
times the y. Ew.
Still not linear.
Still not linear, but still ew. So this one is nonlinear. If my variables are being multiplied together instead of being added together, it's nonlinear. Mostly, if we see anything gross, it's not a line. How about this bottom left one? Nonlinear for a plethora of reasons. Pick one.
Exponent.
Exponents on my x, exponents on my y. This guy's weird. It would be some strange combination of a circle and an oval. Exponents. Too many exponents. How about the right one? On the bottom row. Why? Okay, valid. Absolutely valid. Sometimes blind guess is our answer.
Linear is in order.
Yeah, it's in order. These are just numbers. I can have fractions as numbers. And, just like Cooper said, if we want to get rid of the decimal or get rid of the fraction, I can multiply everybody by 4 to get rid of that fraction. This guy times 4, that guy times 4. If you want to, you can absolutely do this to get this to be y equals, and it's going to wind up being 3x times 4, which is 12x, plus 7 times 4, which is 28. So I can make it be slope-intercept form. That's exactly y equals mx plus b. So this one's linear. Yes, my dear? It can't have like 1 over x plus 4y equals 7. So I can't have x in the denominator. I can't have 1 over y equals x. I can't have y in a denominator. By the end of the school year, we'll play with those. In fact, that's what these guys turn into. Okay, feel a little better? I just felt like we needed a couple more runs through on that before we moved on to pictures. I promise, the pictures are not super duper hard. So we're going to use this for a couple of things. Naturally, if I show a graph, it means I have, for you, a graph. I'll pass them out. Because we're going to use this for 2 things. It's not just going to be linear or non-linear. Not that nice. Okay, so in pass out graphs, we've got 4 graphs. Yeah, I recommend putting them in your notebook because we're going to talk about the next thing using these graphs to do. I recommend it. I'm not going to say you have to. Your notebook is your choice. It's your notebook and your choice. You guys can always make a different choice than me, but I do recommend having them.
Are you upset?
Okay. And again, I always set these up. You don't necessarily have to cut them apart if you don't want to. You can also cut them apart like this or here. But they are set up so that you can, if you want to, just glue them in vertically. We're going to do them in this order. And I always print them out like that so that you can glue them in without cutting them. If you do cut things apart and cut off little strips, please clean up after yourself. So I'm going to ask a super duper complicated question here. Sarcasm. Is this linear or nonlinear? Nonlinear. How do we know? That is not a line. That is a U shape. What's up? So this one is nonlinear. It technically is called a parabola, but we're going to work with that 2 more chapters. Non-linear. That is not all we're doing with this graph, just so we're aware. How about the right-hand one? What do we think, linear or non-linear? This one is linear. I will never, on purpose, try to trick you. I will never give you one that is curved ever so slightly that you can't even see it. I will never on purpose try and trick you. Okay? So it should not ever be close enough that we have to get the ruler out and go, well, it's mostly lined up. It will be clear, because I'm not that mean. I know sometimes we think I'm that mean, but I'm not that mean, I promise. Okay, so that's just one strand of these. The pictures are usually pretty easy for our linear or nonlinear. Is it a line or is it not a line? What we're mostly going to use these graphs for is we've used a word already today a few times when we were talking about these forms. What form did we put this one into? Slope-intercept. What's an intercept? It's where it crosses. So that's what we're going to talk about next. We have 2 different kinds of intercepts. We're going to deal with x-intercepts and we're going to deal with y-intercepts. So x-intercepts are, I think I have my definition on the next page. I want to make sure I give the correct definitions. An x-intercept is the coordinate point where a graph crosses the x-axis. I can talk. So since it is where it is always crossing our x-axis, we know one thing for sure about an x-intercept. Its height is 0. It is always going to be right on the x-axis. So it's going to be some value, whatever our x-intercept is, comma 0 as our ordered pair. Ordered pairs are always written x comma y. But with my x-intercept, I know the y. It's on my x-axis. It is 0. It's locked in. If it's an x-intercept, it has a 0 in the y spot. Very, very similar for my y-intercept. Just every place where we say x, switch it for a y. It's the coordinate point where a graph crosses the y-axis. My ordered pair is a little bit different, but the definition is almost identical. Crosses the y-axis. And its ordered pair, it's not that I know the y this time. This time I know the x. It's going to be written as 0, comma, y. Because if it's on my y-axis, I know it's on that up and down one. All I care about is its height. It's at a 0. So y-intercepts we work with a lot when we're dealing with lines. X-intercepts we are going to deal with all year long in all kinds of different ways, in all kinds of different shapes. So since it deals with all kinds of different ways, and all kinds of different shapes, and all kinds of different things, it actually has 3 synonyms. So I'm going to give you those because there's going to be a lot of times where I just say all 4 words together just to keep them together. So my x-intercepts are also called roots and solutions and zeros. And we will use this over and over and over and over all year long. And a lot of times I will say, all right, so what's our x-intercept or root or solution or zero? And I'm going to say all 4 words because they mean the exact same thing. Because math was invented in about 12 different places across the globe within about 2 years of each other when they came up with these names. So there's a bunch of different names in a bunch of different languages. And we've mostly settled on these 4. At this point, it's not going to be a which words match up to here until we start using them a whole lot more. But I just like to give it to you so we can practice with it, and it's not new when we do it. So what we're going to do is we're going to look at those graphs I gave you, and we are going to find our x-intercepts and our y-intercepts. And we're going to write them as ordered pairs. And that is what we're doing for the rest of today. So, looking at those 2 we just looked at, our linear and nonlinear ones. We're going to find our x and y intercepts. So remember when we're writing ordered pairs, it's always, always, always x, comma, y. That's the way we put the address. We can't switch them, otherwise it'd be like saying Indiana, Indianapolis instead of Indianapolis, Indiana. So my x-intercepts are where it crosses my x-axis. I'm going to put my x-intercepts here. The x-axis is my sideways one, this one here. So where does my green line cross my x-axis? -1 as a point. So we have 1 intercept at -1, comma 0. And we have another one where? 4, 0. Do not smash together and make it -1, 4. That would be here. And this is not an intercept. All right, then let's see about our y-intercept. Where do we have a y-intercept on this one? -2. Again, make sure we're doing x, comma, y. My x in this case is 0. And I know I'm right at the bottom edge. Sorry. I know my picture is gigantor. Make sure I get my card on my way here. Okay. Let's do the one next with the line. What are my x-intercepts going to be?
4.
We have one right at 4. So we have 4, comma, 0. How about y-intercept? There we go. 0, -2. Because that was right here. Okay? Questions on these 2? Let's do the wonky W. This is the 3rd graph on that little thing. It is indeed nonlinear, correct. So let's toss it up there. Nonlinear. Absolutely right. Because there's no way, shape, or form is that a line. So let's think about our x-intercepts. Where do we have x-intercepts?
-3, -1,
Whoop. -3, 0. And What was the next one? Negative 1. 0. It's like y'all just faster than I can go. And at 2. How about y-intercept?
9.
I think it's 12 because they're going up by increments of
12.
Yeah. Catch the scale. 12. It's counted by 4s. So especially when we're looking at like, say homework questions where we take them from the book. This is from the book. The book loves to play games with scales. I'm so happy with it, right? So excited by that. I'm so excited by that. But they love to play games with scales. So make sure we're watching. If they put the numbers in there, they put them there for a reason. So the y-axis is counting by 4. So 4, 8, 12. So my y-intercept is happening at 0, 12. So be super duper duper extra careful. Okay? Questions on that one? We have one more. And it's a table. So I've got the story up here. I didn't print out the whole paragraph. You don't necessarily need the whole paragraph. But we're going to take this information about Ricardo's rocket and try and find our x and y intercepts and figure out what the heck those mean. So think back to our definition. Remember, our x-intercepts happen at x, 0. And our y-intercepts happen at 0, y. So I agree. Definitely 8's going to be something because 8 has a 0 with it.
0, 15 is y.
And 0, 15 is going to be another one. And good. If it helps you, write them up there like this because you're exactly right. The 0, 15, it's got the 0 in the right spot. It's in the x spot. So 0, 15 is my y-intercept. So my y-intercept is 0, 15. What's my x-intercept then? 8, 0, because I have a 0 in my y space. So I love that we found them so fast. Fantastic. What does 8, 0 mean in terms of the rocket?
8 seconds behind.
Excellent. Fantastic. Perfection. When in doubt, grab your titles. At 8 seconds, my height is 0. So our x-intercept means at 8 seconds, or at 8 time, I do not even care if it's grammatically logical, like 8 time, height is 0. And I can never remember how many C's are in seconds. Oh, and we don't have seconds on there. Oh, there we go. Height is 0. So what's my y-intercept in context? At time 0, height was 5, or height was 15. Yeah. So at time 0 would also be known as launch. The height is 15. And you can do it either as is or was. I do not care about tenses. So what this means is his balcony is 15 feet high, because it says it launched it from the balcony. And it hit the 0 height, so ground, it landed after 8 seconds. So when we say to put something in context, that's what we mean. When in doubt, grab the labels off your table. Use those. Okay? The labels are there to give you context. Questions? Ta-da! That is the end for today. So, homework 1-1 is due tomorrow. And this is, no, I'm fixing this. It is not due Monday. It is due Friday. Because we're going to finish what we need to talk about it tomorrow. That gives you extra day to turn it on Friday.
Wait, we got homework 2 already?
Homework 2 is in my hand right here. I'm handing it out. Homework 1 is due tomorrow. what we did today is homework 2. We are also going to talk about like the last 3. You can do everything up to these last 2 here with what we did today. So we're going to talk about those last 2 tomorrow. So if you do what we can today, tomorrow you'll only have 2 math problems to do, and then you'll be done with the homework. Love that. Hey, it's highly probable. They like to stay together. Sometimes I'm bad at counting, sometimes it's just static. What's up? I gave you guys an extra one too. I think these ones are staticky then. Because if it happens 2 times in one class, usually it's not my fault entirely. All right, so we're gonna have announcements here in just a couple of minutes, and you don't have to listen to me yell. We're gonna get RDTV today.